So I am hoping you all see a great blue marble.
Yes.
All right. So this is the first picture of the Earth fully illuminated that any of us ever saw, taken back during the last of the Apollo lunar missions back in 1972. So until this image was published, most people's idea of the globe was that small little globe in their school classroom with the tiny little squiggly lines denoting arbitrary borders and countries. But this image shows no borders, no countries, and it really changed the way that humanity thought about our common home. It reminds us that we're all connected and that our actions have an impact on our planet. So the three questions: must we change? Can we change? And will we change in our response to the climate crisis? First of all, must we change? What are the immediate reasons for the change, and what waits for us around the corner if we don't act? The scientific community all around the world has been telling us for a long time that yes, we must change, and now Mother Nature is sounding the alarm. So let's start with the sky. It's not a vast and limitless expanse the way it appears to us as we stand on the ground and look up. In reality, there's just a thin shell of atmosphere that surrounds the planet. Here we see the sun shining over Earth's horizon through the two lowermost layers of the atmosphere. This is a photo taken from the International Space Station. Note the slightly curved horizon. Take that, flat earthers. Anyway, so the question is, what are we putting into this thin layer every day? And the answer is 152 million tons of man-made global warming pollution into the atmosphere every single day. And that pollution, especially carbon dioxide, is building up and trapping the heat. So let's take a look at how that extra CO2 traps all this heat energy and where it goes. Quick science lesson: energy comes from the sun, goes to Earth in the form of light, which is then absorbed by the Earth and warms. Some of that energy in turn is re-radiated from the Earth in the form of heat, infrared light really. And in turn, some of that outgoing heat is trapped by the atmosphere. And now this is a good thing. This has kept our planet at a nice, stable temperature. However, we have been thickening the atmosphere by filling it with heat-trapping pollution. More heat energy is trapped, and it is warming our planet at an unprecedented rate. So where does this extra CO2 come from? There are many sources, from fertilizers, forest burning, oil production. But the main source and the cause of the rising global temperatures that we are seeing today is the burning of fossil fuels. Fossil fuels still provide more than 80% of the world's energy. Fossil fuel use and emissions have gone up dramatically since World War II. And in the last few years, there was a leveling off as the world adopted more and more clean energy solutions. Fortunately, there was another spike in recent years. And as a result, this pollution being trapped in the atmosphere, global temperatures have risen dramatically, especially note in the last 40 years. 19 of the 20 hottest years ever measured have occurred since 2001, and the hottest year of all is 2016. So the heat itself is a problem in many parts of the world, and in many parts indeed of this country. It affects not only people, but animals, crops, weather. Here's the gentleman who succumbed to heat exhaustion. But where else is this heat ending up? So on a global basis, more than 90% of all the heat energy trapped is going into the oceans. And this heat makes ocean-based storms like hurricanes, typhoons, and cyclones stronger and more destructive. Indeed, half of the increase in global ocean heat content has occurred in less than the past 20 years. Here's an image of Hurricane Florence with the coast of the Carolinas from 2018, which produced record-breaking rainfall across North and South Carolina. In addition to providing extra fuel for storms, the extra heat also disrupts the water cycle. If you guys remember from your high school science, the 3 steps of the hydrological cycle, where we have water that's evaporated, water vapor, which then cools, condenses into precipitation, whether that be rain or snow, which in turn goes back to the oceans and then can be evaporated, and that continues the cycle. Now, the amount of water vapor that evaporates off the oceans increases as the ocean warms, and that water vapor is carried over the land and often falls in much bigger precipitation events. When the land can't absorb the water that falls, these larger storms and downpours, that's when we see the floods and the mudslides. Here's kind of an example of a supercell from Montana back in 2010. You can kind of see that giant column of water just erupting from the middle. Or flooding events. For example, here's one from India in 2015. And I actually have a kind of a personal story about this. I have several coworkers who work in Pune, India. And last week, if you've seen the news, they were inundated with floods. And one of my coworkers actually got hit with 3 feet of water in his house. So their power was cut and they had to quickly evacuate and go to their relatives. So this is happening live. So another thing that people sometimes wonder is, how can global warming be blamed for causing more precipitation and flooding and at the same time more drought? The answer is that the extra heat trapped by rising levels of greenhouse gases actually leads to both. And as the climate changes, precipitation patterns also change, leaving some places with less rainfall than before. The extra heat basically turns the atmosphere into think of it as a more absorbent sponge, which both soaks up more moisture from the ground and disgorges more precipitation when it's disrupted in some way. Changing precipitation also leads to drought and water shortages. Here's kind of a classic example from Brazil during a severe drought. And the wildfires. With higher temperatures, we also get more wildfires and more intense fires. You can see here the number of large fires corresponds closely to years with higher average temperature in spring and summer. Today, the fire season in the western U.S. is more than 100 days longer than in the 70s. And in more current event news, right now, we know that we're seeing massive fires in Canada, reddening the sun, and even we've had some air quality alerts here in Minnesota over the past couple of weeks. So again, more change is happening right now. And again, speaking of those fires, in 2016, here's a shot from Alberta and a long line of evacuees trying to escape. So from an industry standpoint, the insurance industries have been taking note, and they're potentially on the hook for hundreds of billions of insured losses due to climate change. The number of climate-related extreme weather events has been going up worldwide. In the last 2 years, rank among the top 10 for most expensive overall disaster losses, with over 160 billion in 2018 and 140 billion in 2019. And then there's the glaciers. Climate change is melting glaciers around the world. And these are glaciers that many people depend on for fresh water and crop irrigation. The initial shot was back from 1935, and this one is the same glacier, well, what's left of it, from 2013. NASA has precisely measured the decline of the massive ice in both Greenland and Antarctica, and all this extra melting is raising sea levels worldwide. There's a shot of Miami Beach, Florida, and this is not a rainy day. This is just a result of high tides. So it's happening in Miami and other cities and areas around the world like Venice. And this situation will only get worse as sea levels continue to rise. Miami is the #1 city at risk in terms of assets at risk, along with Guangzhou, China, and New York, among others. As far as population, we see that many huge cities are very much in danger. So the question is, if parts of these cities become uninhabitable, where are the people going to live? Or where are they going to go? The Department of Defense has warned about refugee crises connected to the climate crisis, as well as pandemic diseases, water shortages, and food shortages. Crops are now feeling direct effects of climate change as well. Heat stress is now beginning to decrease crop yields from rice, corn, and soybeans. Exposure to higher levels of carbon dioxide also decreases the nutrient content of many of these staple crops, like rice, wheat, and soy that we depend on. And then there's the medical front. Diseases which used to be confined to equatorial regions are now migrating north and south as climate change makes the local environments there more hospitable to a variety of infectious diseases. Modern transportation and air travel, they do play a part, but the potential range for many diseases expands as regions farther north and south get warmer. And this means there are more and more places where disease like Zika, for example, could take root. The mosquito that spread Zika is now covering a wider range in a warmer, wetter world. And in warmer temperatures, the virus incubates faster, and mosquitoes breed more and are able to transmit the disease longer. The health impacts of the climate crisis are often overlooked, but these are going to affect millions of people in coming years. And then there's the animals. We are at the beginning of what appears to be Earth's sixth mass extinction event. Climate change, along with other factors such as ecosystem loss. Think about the burning of the Amazon rainforest, for example. It's contributing to the worst extinction event since the extinction of the dinosaurs 65 million years ago. So all of these threats, we haven't even included all of them. And the fact that the World Economic Forum says climate change is the #1 threat to the global economy helps to answer the question, must we change? But what about the second question? Can we change? Well, the answer is yes, and we have solutions. Some good news. For example, looking at renewable energy and wind in particular. So wind energy was predicted to provide 30 gigawatts of electricity worldwide by 2010. And as of 2019, we've exceeded that prediction by over 22 times. Wind energy construction around the world is increasing exponentially. And wind energy could supply 40 times more electricity than the entire world currently uses. Solar energy is an even more dramatic story. 18 years ago, the best projection was that we could install 1 gigawatt of solar energy capacity per year by 2010. But by 2010, we had exceeded that goal by 17 times, and by 2019, had exceeded the goal by 121 times. And even more dramatically than wind, we see exponential growth in the amount of solar energy being installed around the world. And just as we've seen with other technologies, such as computer chips and cell phones, solar costs have fallen dramatically. In some regions, solar energy is less than half the cost of electricity from burning coal. In many countries, where there's no universal electricity grid, we are also seeing consumers and businesses leapfrog old technologies and install solar panels in places that have long been denied access to electricity. For example, here's a solar panel on a rural roof in South Sudan. Chile is a true solar success story thanks to early policy decisions. It started off slowly, but by the end of 2018, they had planned on 16.67 gigawatts of solar projects approved, installed, or under construction. And there are many regions in the world where this type of growth and development is possible. Every hour, the Earth gets as much energy from the sun as we need to run the entire global economy for a year. So if we can increase just a fraction of this energy that we harvest and use, we can make a lot of progress towards solving the climate crisis and helping local economies at the same time. Another component of this is battery storage. Batteries allow us to store excess solar or wind energy and then use it during times when the sun isn't shining or the wind isn't blowing. So batteries are also critical for the electric vehicle market. In 2016, the global cumulative storage capacity approached 3 gigawatts, almost 2 times the storage capacity seen in 2011. Another direct impact of technology is LED lights. They have virtually taken over the lighting market. If you've seen the lighting aisle over at Home Depot, it's getting really hard to find incandescent bulbs. Usually they're on the bottom. They're, away from easy viewing. So as energy efficient technologies like LEDs become even more prevalent, people will save money and they will reduce emissions by cutting down on the amount of electricity that we use. Auto manufacturers have committed to increasing development and production of electric vehicles. I know that Ford and GM, for example, have introduced electric truck prototypes. And the listed manufacturers have all committed to offering or preparing to offer electric vehicles. So this is another part of the sustainability revolution. So can we change? Do we have the solutions? We do indeed. But then there's the final question, will we change? Well, in December of 2015, at the Paris climate negotiations, every nation in the world agreed to phase down greenhouse gas pollution and to net zero emissions as early in the second half of this century as possible. And thankfully, the United States rejoined those accords early this year. But climate action isn't just about what countries do. We all have to take the lead in climate. We're seeing corporations, states, and provinces and cities commit to reducing emissions. Marches, demonstrations, and even the group that we have right here. We're all kind of joining together to make the changes necessary to solve this crisis. So please join those who are speaking out and making everyday choices to fight the climate crisis. Use your vote because your world depends on it, and we need your help. I just want to kind of wrap up with this last image. This image is Earth, but it was taken in 1990 by the Voyager 1 spacecraft, just beyond Neptune's orbit, about 3.7 billion miles from the sun. The idea was to have Voyager turn and capture a family portrait of the solar system planets before heading out beyond the solar system. It was suggested by the late Carl Sagan, who wrote about that pale blue dot. Everyone you love, everyone you know, everyone you have ever heard of, every human being who ever was, who lived out their lives on a mote of dust suspended in a sunbeam. So I believe this image represents our responsibility and our duty to care for that tiny little speck in our corner of the universe.